All right, folks, on to problem number 7 from the ideal gas equation homework. Let's get to it. At 422.2 Kelvin, a sample of carbon tetrafluoride gas has a pressure of 361.2 kilopascals. If the gas is stored in a 5-liter container, how many grams of gas do you have? Now, again, this is a hard problem. Each one of these problems, 5 through 8, has a little tiny trick to it. And in this one, I want an answer in grams. Now, you can't get that directly with the gas law equation. You're going to have to solve for moles of gas and then convert it into grams. So let's walk through this and see what it looks like. All right, so here I go. For this question, I will do purple. Here we go. Problem number 7. Now, I'm going to get started, of course, with the ideal gas equation. The pressure of a gas times the volume of the gas is equal to the number of moles of gas times the gas constant times the temperature in Kelvin. All right, so now I'm going to start plugging in the things that I know from the equation. It mentions, and I'm looking at the other sheet here, that the temperature is 422.2 Kelvin. That's the temperature. So 422.2 is the temperature. What else does it say? It says that the gas has a pressure of 361.2 kPa. 361.2 kPa. And it's important to pay attention to that variable. It's kPa. And we need to know that for the gas constant R. All right, what other things do we know here? We know that we have to solve for number of moles because we're then going to use that to get grams. The volume of the container is, according to this problem, 5 liters. All right, I'm going to leave it simple. 5 liters. All right, we have to find the number of moles. Now, what is the gas constant here? Well, it's the gas constant for kPa, which from your notes and from the worksheet is, and let me pull it up and take a look. You should be checking your notes. All right, you should check your notes. kPa is 8.314. 8.314 liter kPas per mole Kelvin. 8.314. 8.314. Okay, so to solve for the number of moles, I got to get this jabroni by itself, which means I need to divide. I need to divide both sides by 8.314. 8.314. And I need to divide both sides by 422.2. 422.2. Okay, so there we go. There we go. Now, I got to solve for this thing, all right? I will tell you what the most common mistake is that students make when trying to solve this kind of equation. They go to their calculator and they plug in 361.2 times 5 divided by 8.314 times 422.2, and there is a problem. There is a problem because based on how they entered this into the calculator, you're going to end up with a number that is multiplied by 422.2 when it should be divided. It's on the bottom of the fraction line. So if you're plugging this into your calculator, you need to do something. You got to put this in parentheses. You got to make sure that the whole bottom of this fraction stays together. Or alternatively, you can figure out the top value first, the bottom value second, and then divide them accordingly. So I'm going to actually do that. All right, I'm going to take my time on this problem. All right, I'm going to take my time on this problem. So here I go. All right, we're solving for number of moles. All right. The top of this is 361.2 1.2 times 5. All right, the top is 18. No, I don't like that color. The top is 1,806. All right. The bottom, let's see here, is 8.314 times 422.2. And that is 3,510. All right. So this number is roughly going to be like 0.5. Let me plug that in. 1806 divided by 3,510. And I get, yeah, the number of moles present is 0.5145 moles. So roughly half a mole of gas. All right, half a mole of gas. Now, if you were reading carefully, if you were reading this problem carefully, you'll notice that we're not asking for moles. We want grams. We want grams of this substance. We want grams of carbon tetrafluoride. All right? So to get grams, we have got to take the number of moles, 0.5145. And we have to multiply it by the molar mass of carbon tetrafluoride. All right, so I'm going to go up. I'm going to Google CF4 molar mass, and I get 88.00. Okay, again, this is a carbon plus 4 fluorines from the periodic table. All right, it is 12.01 plus 4 times what is fluorine? Fluorine molar mass 19, flat 19. All right, flat 19. So that's where that number came from. So 5.5145 times 88, and I get roughly 45.3 grams. 45.3 grams. 45.3 grams. Let me plug that into my worksheet and see if I got it. 45.3. Oh, yeah. Did it. All right. Bye.